Hello everyone, so this is the last session of computing square. So in the previous two videos, I covered the basics of computing square. So basically in this video, I want to cover the application of the computing square. Basically, how is the computing square method useful? So basically, if you have a standard form of a quadratic function, you can actually turn this to the vertex form by doing the computing square. So basically in the previous video, I showed you how you can turn the vertex form to standard form. So in this video, I want to show you how you can turn the standard form of equation to the vertex form by doing the computing square method. So we're going to look for one example. So y is equal to x squared plus 2x plus 4. And I'm going to turn this standard form to the vertex form here. So the vertex form we have y equals a x minus p squared plus q. So basically I need to figure out these three constants here. So basically I need to first figure out the a value. So a value is the leading coefficient of the x squared term. So what is the coefficient of the x squared coefficient here? So the coefficient in the x squared term equals to 1. So which means that the a value equals to 1. So next I want to figure out what is the value of the p value. So I also need to find the area, this one x minus p squared. I also need to rewrite this format into x minus p squared. So remember, x minus p squared is area of the square. So basically, I just need to assume this one is my area of the square, but I'm not sure. So how could I make sure this one is area of the square? So basically, if I want to figure out if this one is my area of the square, I need to check. I need to take these two terms and do the computing square if I want to check if this whole thing is the area of the square. So how could we check this? Remember from the previous video? So now I want to check if this is my area of the square, so how could we do that? So I just take these two terms, x squared plus 2x, and do this term. So remember how we can compute the square for this one? So I just take the middle term coefficient and we divide it by 2. So always divide it by 2 if I have the middle coefficient, and we do the square. So now what is the b value for this one? So b value equals to 2 over 2. So basically, I can rewrite this expression as x plus 1 squared. So definitely this one is not equal to this one. But I already figured out the p value. So p value is this one, is negative 1. So because this one is positive, so I need to assume that the p value is negative. So basically, we have the last term here. I need to figure out the q constant. So I need to figure out how many do I need to add if I want to get the 4 here. So currently we have x squared plus 2x plus 1 for this equation. So how many do I need to add if I want to get to the 4? So which means that I need to add 3 if I want to make this equation equals to the previous one, x squared plus 2x plus 4. The q value here is equals to plus 3, it's a positive 3. So basically I can rewrite this expression as x plus 1 squared plus 3 for my standard form equation. So next I will show you what you usually learn in school. So this is the second method. So it's a traditional method. So I want to turn this term, the standard form of the function, x squared plus 2x plus 4, to the vertex form. So basically, the teacher usually to do this. When you do this, you also need to complete the square for these two terms, right? So I'm also breaking up this equation into two parts. So x squared plus 2x and plus 4. So the reason why I need to separate this because I need to complete square for this one. So I need to add the number here in order to complete the square. So I can write this formula into this format, x minus p squared. So how should I do that? So basically I need to add the number, the coefficient. I take out this coefficient and divide it by 2 and we do the square. So the b value equals to 1. So a lot of students will forget if they add the new numbers here, they usually forget to minus the new number. So basically I just want to make this equation equal. So this equation must be equal to this equation. So if I change the number, I need to minus back. So the reason I need to write this format because I need to turn this one into this format. So because the b value equals to 1, so I know that the value here, the p value must be -1. So the vertex at the x coordinate is -1. So, and I just write this to x plus 1 squared. So next part, I want to figure out the q value. So q value is -1 plus 4. So 4 minus 1 give us the 3. So we have the vertex form equation y equals x plus 1 squared plus 3. And it's the same as the first one.